For the last 2 decades, we've been told there is only one path to energy independence. Solar panels. Cover your roof. Install batteries. Sign the financing agreement. And maybe, just maybe, you can escape the utility grid. But what if one of humanity's oldest energy technologies never stopped evolving? What if the air moving above your roof right now contains more usable energy than the sunlight hitting it? And what if a new generation of wind turbines has quietly solved many of the problems that made small-scale wind power fail in the past? Because hidden behind the shadow of the solar industry, engineers have been building something remarkable. And by the end of this video, you'll understand why some experts believe the future of energy independence may not come from the sun alone. It may come from the wind. If you're interested in forgotten technologies, engineering breakthroughs, self-sufficiency, and the science shaping our future, make sure to subscribe. Because today, we're exploring 6 extraordinary wind turbines that are challenging everything we think we know about off-grid power. Walk through almost any off-grid community today, and you'll notice something. Solar panels are everywhere. They've become the symbol of energy independence. But here's the strange part. Solar only works when the sun shines. At night, production stops. During storms, output drops. And during winter, when energy demand often rises, solar generation can fall dramatically. So why did nearly everyone bet on a technology that spends half of every day inactive? The answer is surprisingly simple. Because small-scale wind power earned a bad reputation. Early residential turbines were noisy. Many were unreliable. Some barely produced enough electricity to justify their installation costs. For decades, homeowners who experimented with wind energy often ended up disappointed. And so the industry shifted toward solar. But while public attention focused on photovoltaics, engineers continued working behind the scenes. Quietly, relentlessly, solving one problem after another. And that leads us to an important question. What if modern wind turbines are completely different from the machines most people remember? To answer that, we need to understand something fundamental about physics. Imagine standing outside on a sunny day. Sunlight feels powerful. After all, it can warm your skin from nearly 150 million kilometers away. But sunlight and wind represent 2 very different forms of energy. Solar panels capture photons, tiny packets of light. Wind turbines capture moving mass. And moving mass contains enormous amounts of kinetic energy. Here's the surprising reality. Double the wind speed and the available energy doesn't double. It increases by roughly 8 times. This relationship is one reason wind can become incredibly powerful. A strong winter storm passing over your property may contain enough energy to power an entire home for days. The challenge has never been finding the energy. The challenge has been capturing it efficiently. And this is where the story takes an unexpected turn. Because some of the newest turbine designs barely resemble traditional windmills at all. One of the biggest barriers to residential wind power isn't engineering. It's regulation. Many homeowners simply cannot install a 60-foot tower. Zoning restrictions, neighborhood associations, and local building codes often make it impossible. So engineers asked a different question. What if the turbine didn't need the tower? The TESIP Atlas approaches wind energy from an entirely different angle. Instead of chasing the wind like a traditional propeller, it accepts airflow from every direction. Its vertical axis design thrives in the chaotic turbulence found around homes, fences, and rooftops. No constant reorientation in a massive mast. No towering structure dominating the skyline. Sometimes innovation isn't about making something bigger. Sometimes it's about making geometry smarter. Now let's move from simplicity to durability. Most modern technology relies on sensors, computers, software, and electronics. But every additional component creates another potential failure point. The SD6 takes the opposite approach. Engineers in Scotland designed it around mechanical self-regulation. Instead of relying on software to survive storms, the blades physically adjust themselves through centrifugal force. As winds increase, the rotor automatically changes its behavior. No computer required. No emergency shutdown. No complex intervention. It's an old engineering philosophy. Build the intelligence directly into the machine itself. And in extreme environments, that philosophy can make all the difference. Then comes one of the most unusual designs ever developed. The Liam F1. At first glance, it looks almost like a giant seashell. But appearances can be deceiving. The design is inspired by the Archimedes screw, a technology whose origins stretch back more than 2,000 years. Its spiral shape guides wind through the rotor in a carefully controlled path. The result? Lower noise, better performance in turbulent conditions, and a design that can continue operating efficiently even when the wind arrives from awkward angles. For suburban environments, that's a significant advantage. Because real-world wind rarely behaves as neatly as engineering textbooks suggest. Next comes one of the most fascinating concepts on this list. Most turbines become less efficient when placed close together. The turbulent wake from one turbine interferes with the next. But flower turbines challenge this assumption. Their vertical design can actually benefit from neighboring units. Instead of fighting one another, they can work together. The airflow produced by one turbine helps energize the next. It's known as the cluster effect, and it completely reverses a rule that has shaped wind farm design for decades. Even more interesting, the design is nearly silent and dramatically reduces bird strike risks. A rare example where efficiency and environmental considerations align. Not every innovation has to be revolutionary. Sometimes refinement matters more. The Primus Air series focuses on simplicity. Compact, reliable, easy to install. Originally developed for marine environments, these turbines were built to survive corrosive saltwater, harsh weather, and constant vibration. And because much of the control electronics are integrated directly into the unit, installation becomes remarkably straightforward. For cabins, boats, remote communication systems, and emergency backup power, simplicity is often the ultimate luxury. And then there is the turbine designed for places where nature refuses to cooperate. Iceland, mountain ridges, Arctic conditions, regions where storms can destroy conventional equipment. The Icewind turbine was engineered specifically for survival. And survival, as we'll soon discover, may be one of the most valuable forms of efficiency. Here's something many people don't realize. The effectiveness of wind power is highly dependent on location. A turbine installed in the wrong place can perform terribly. The exact same turbine installed just a few miles away can become incredibly productive. That's why engineers obsess over wind data. Not guesses, not assumptions. Data, average wind speed, seasonal patterns, turbulence levels, wind direction frequency. Every one of these factors matters. Studies consistently show that properly sited turbines can produce substantial annual energy output, especially in regions with strong and consistent winds. And this creates an important insight. The debate between solar and wind is often framed incorrectly. It isn't solar versus wind, it's solar plus wind. Solar performs best during sunny days. Wind often peaks during storms, at night, and throughout winter. In other words, they naturally compensate for each other's weaknesses. This complementary relationship may be the real breakthrough. Not replacing solar, but strengthening it. But before we crown wind power the ultimate solution, we need to confront reality. Because there are reasons residential wind never became mainstream. First, location matters enormously. A poor wind site can destroy project economics. Second, installation costs can escalate quickly. Towers, foundations, permits, electrical integration, maintenance access. These expenses often surprise first-time buyers. Then there's turbulence. The same buildings that people live in also disrupt airflow. A turbine mounted too low may spend much of its life operating in chaotic, inefficient air, and perhaps the biggest challenge of all is inconsistency. Not every property has enough wind. Not every region has suitable conditions. This is why experts recommend something many people skip entirely. Measurement. Before buying any turbine, collect data. Install an anemometer. Track wind speeds for months. Understand the resource before investing in the hardware. Because the difference between a great wind site and a poor one can determine whether a turbine becomes a valuable asset or an expensive decoration. So where does residential wind power stand today? The answer is more nuanced than the marketing brochures suggest. For urban homeowners with limited wind exposure, solar often remains the simpler option. For remote properties, farms, coastal regions, mountain ridges, and open plains, wind can become extraordinarily valuable, particularly when paired with solar. Modern turbines are quieter, smarter, more durable, and dramatically more specialized than their predecessors. Some are optimized for cities, some for storms, some for low winds, others for extreme environments. The technology has matured. The question is whether consumers have noticed. Because while the world focused on solar panels, wind engineers quietly reinvented the small turbine from the ground up. So, does wind power deserve a second look? Absolutely. But not as a miracle technology, and not as a replacement for everything else. Its greatest strength lies in partnership. Wind fills the gaps solar leaves behind. It works through winter storms. It works at night. It works when clouds cover the sky. And perhaps most importantly, it reminds us of something humanity has known for thousands of years.